Hello everyone, we are solving question 31 of GATE 2018 chemical engineering paper, and the question is the decay ratio for a system having complex conjugate poles as minus of 1 by 10 plus or minus of j 2 upon 115 is dash. So here we have been given complex conjugate poles and have been asked to find the decay ratio. So the system that we are considering is a second order system. So for a second order system, we can write the transfer function as g of s is equal to kp upon tau square s square plus 2 zeta tau s plus 1. And the poles are the values of s for which the denominator is 0. So basically, the value of s that satisfies this equation, that is denominator equal to 0, will be our poles. So we can solve this equation for s and find the poles of the system and then compare it with the given complex conjugate poles to find the value of unknown parameters over here, that is tau and zeta. So let's just do that. So since this is a quadratic equation, we can write the roots of this equation as s is equal to minus of b plus or minus under root of b square minus of 4ac upon twice of a. So over here, b is this term 2 zeta tau, a is tau square, and c is 1. Let's just replace those values to find the roots of this equation. So this will become 2 zeta tau plus or minus of under root of b square will become 4 zeta square tau square minus of 4, a is tau square, and c was 1 upon twice tau square. You can simplify this further to write, so this 2 will get cancelled and it will become minus of zeta upon tau plus or minus under root of zeta square minus 1 upon tau. In this question, we have been given the complex conjugate poles, that is, they are in terms of this j. So we can take minus 1 common from this bracket and then rewrite this equation as minus of zeta upon tau plus or minus j 1 minus zeta square upon tau. So for this given system, we calculated the conjugate poles, so by this formula, and now we'll be comparing it with these roots that we have been already provided to find these values of time constant and zeta. So if we compare the first term over here, so that is, we have been given minus of zeta upon tau is minus of 1 by 10. That is, we can write it as zeta upon tau is equal to 1 by 10. That can also be written as tau is 10 times of zeta. Now the other second term is under root of 1 minus zeta square upon tau, and from here we can write it as 2 by 15. 2 upon 15. We can replace the values of tau from this and we will be getting upon 10 zeta is equal to 2 by 15. Let's just simplify it. 2553. And we can take the square of this equation and we'll be getting 1 minus zeta square upon this will be zeta square is equal to, so this will become 4 by 3 and square of 4 by 3 will be 16 upon 9. This we can write it as 9 minus zeta square, 9 minus 9 zeta square is equal to 16 zeta square. So we will be having zeta square is equal to, so 16 plus 9 is 25 and 9 by 25. So from over here we can calculate zeta as under root of 9 by 25, so it will become 3 by 5 is equal to 0.6. So the value of damping factor, we calculated it as 0.6, and in the given question we have to find the decay ratio. And the decay ratio we can define it using the formula exponential of minus of 2 pi zeta upon under root of 1 minus zeta square. We can replace the value of 0.6 in this equation, and we will be getting the root of 1 minus 0.6 whole square. So this will become exponential of minus of 4.71, and we can again calculate the value and find the decay ratio as, so this value will be somewhere around 9 point something into 10 raised to minus 3. So from the complex conjugate poles, we found the value of damping factor, and using the formula of decay ratio and the damping factor, we calculated the numerical value of decay ratio is 9 into 10 raised to minus 3. And from the given options, we can select option C as the correct one.